Raw titanium ore arrives at the remote processing facility, where extreme heat purifies the metal for processing.
Molten alloy flows through graphite molds, cooling rapidly to form the initial solid ingots of high-grade titanium.
These heavy ingots are transported via automated heavy-duty belts to the primary rolling station for initial flattening.
Hydraulic rollers compress the heated metal with immense force, creating a dense and durable sheet of alloy.
Precision lasers slice the flattened titanium sheets into rough blocks that will eventually form the device chassis.
Automated robotic arms sort the cut metal blocks, inspecting each one for uniform thickness and surface quality.
The metal blocks undergo a rigorous chemical bath to remove any oxidation or impurities from the surface.
Computer numerical control machines begin the milling process, carving the solid block into a complex geometric frame.
The high-speed drills hollow out the interior compartment to accommodate the battery, logic board, and camera components.
Coolant sprays continuously over the friction point to prevent overheating while carving delicate button slots and ports.
Abrasive belts smooth the rough edges of the machined frame, preparing the metal for the texturing process.
Fine ceramic beads are blasted against the titanium to create a uniform, matte texture across the surface.
Technicians carefully mix a custom orange pigment designed to bond molecularly with the porous titanium oxide layer. The frames are submerged into an electrified solution, opening the microscopic pores of the metal for coloring. Electrical current drives the orange dye deep into the surface, creating a finish that will never chip. The frames emerge with their signature orange hue before being rinsed with deionized water to seal the dye. A high-precision laser etches the company logo onto the back panel, revealing the raw titanium underneath. Optical scanners inspect the color saturation to ensure the orange shade matches the strict design specifications perfectly. The finished chassis moves through an airlock into the clean room, where the internal components are assembled. Robots apply a precise layer of thermal adhesive to the inner chassis to assist with heat dissipation. In a separate facility, large silicon wafers are sliced into the individual processors that power the device. The central processing unit is mounted onto the main logic board using surface mount technology and solder. The board passes through a reflow oven where heat permanently bonds the electrical components to the circuit.
Cameras photograph the completed circuit board to verify that every microscopic connection has been soldered without error.
Technicians gently lower the completed logic board into the chassis, aligning it with the pre-drilled screw mounts.
Automated screwdrivers secure the board with exact torque settings to prevent damage to the delicate internal tracks.
The charging module is inserted at the base, connecting directly to the main board via ribbon cables. Stereo speaker units are pressed into the acoustic chambers, sealed with gaskets to ensure water resistance ratings. The linear oscillation motor is installed to provide precise haptic feedback for user interactions and system alerts. A circular array of magnets and a copper induction coil are attached to enable wireless charging capabilities.
Sheets of ceramic-infused glass are cut to size using diamond-tipped tools to form the front display cover.
The glass undergoes an ion exchange process in a potassium salt bath to increase its resistance to shattering. Rotating pads polish the edges of the glass to a microscopic smoothness to prevent stress fractures from forming.
The organic light-emitting diode panel is vacuum laminated to the cover glass to create a singular display stack.
Each screen is powered on to test for dead pixels and color accuracy before final assembly integration.
In the optics laboratory, precision lenses are stacked and aligned to create the complex multi-camera system module.
High-resolution sensors are bonded to the lens assembly, converting optical light into digital data for image processing.
The completed camera module is lowered into the chassis, fitting snugly into the machine.
A metal bracket secures the camera connectors to the board, ensuring they remain connected during drops or impacts.
Lithium-ion cells are manufactured and tested for capacity retention before being approved for installation in the device. Pull-tab adhesive strips are applied to the battery, allowing for easier removal during future repairs or recycling. The battery is pressed firmly into the chassis cavity, occupying the remaining space around the main logic board.
A technician connects the power supply ribbon cable, energizing the system for the first time in the process.
The biometric sensor array and front-facing camera are installed at the top edge of the device frame.
A robotic dispenser lays a continuous bead of waterproof adhesive around the perimeter of the titanium frame edge.
The display cables are connected to the logic board before the screen is aligned for the final closing.
A calibrated press lowers the screen onto the frame, activating the adhesive seal to ensure water resistance integrity. 2 pentalobe screws are inserted at the base of the device to mechanically lock the display in place. The fully assembled device passes through a final cleaning station to remove any dust or fingerprints from handling.
Automated systems boot the device, displaying the manufacturer logo as the operating system loads for the first time.
Robotic fingers rapidly tap and swipe across the display to verify touch sensitivity and multi-touch gesture recognition.
The device enters a dark box where it captures test images to calibrate focus, exposure, and color balance.
Sample units are submerged in pressurized water tanks to ensure the adhesive seals meet strict waterproofing rating standards.
Randomly selected devices undergo tumble testing to simulate years of daily wear and accidental drops on hard surfaces.
In an anechoic chamber, microphones measure the audio output to ensure the speakers are clear and distortion-free.
Plugs are inserted and removed repeatedly to test the physical durability and electrical connectivity of the charging port. A high-resolution laser scanner maps the exterior surface to detect even the smallest cosmetic scratch or imperfection. A final manual inspection is performed, where technicians wipe the screen and check the device under bright lights. A protective paper film is applied over the front display to shield the glass during shipping and unboxing. Cardboard sheets are folded by automated machines to create the slim, environmentally friendly retail packaging for the device. A braided charging cable is coiled and placed into the bottom compartment of the box, alongside the documentation.
The pristine orange device is placed face down into the box, resting securely in the recycled paper tray.
The lid is placed onto the box, designed to slide down slowly due to the precise air friction. Adhesive security seals are applied to the back of the packaging to guarantee the device has not been opened.
Printers mark the exterior label with the unique serial number and configuration details specific to the enclosed device.
Completed retail boxes slide down the main chute, heading toward the palletizing area for bulk shipment and distribution. Large robotic arms stack the individual boxes onto wooden pallets in a precise interlocking pattern for maximum stability. The stacked pallet is spun on a turntable, while plastic film wraps tightly around it to secure the load. Forklift operators lift the heavy pallets and transport them to the loading bay, where trucks are waiting outside. The pallets are loaded into temperature-controlled shipping containers that protect the batteries during their long global transit journey. Trucks depart the manufacturing facility, carrying the initial wave of devices to distribution centers around the entire world. Air freight logistics teams load the pallets onto cargo planes to ensure rapid delivery to distant international markets. The aircraft takes off, beginning the final leg of the supply chain that connects manufacturing to the consumer.
At regional hubs, the bulk shipments are broken down and individual units are sorted for delivery to stores.
Local courier vehicles navigate busy city streets to transport the new devices to retail locations and customer homes.
Retail employees carefully stock the shelves, arranging the boxes to create an appealing display for the launch day.
Customers arrive at the store, eager to see the new orange titanium finish in person for the first time. Demo units are secured to the wooden tables, allowing visitors to touch and experience the new hardware features.
A transaction is completed, and the sealed box is handed over to the new owner of the device.
In the home environment, the user peels back the security strips, breaking the seal to open the packaging. The lid is lifted to reveal the orange titanium back glass, gleaming under the ambient light of the room. The user peels away the protective paper sheet from the front display, revealing the pristine ceramic shield glass. A long press on the side button initiates the boot sequence, bringing the sophisticated internal electronics to life.
The welcome screen cycles through various languages, inviting the user to begin the software setup and personalization process.
The user rotates their head to map their facial geometry, securing the device with advanced biometric authentication technology.
Wireless data migration transfers photos, messages, and applications from the old device to the new hardware seamlessly.